Hi, today we're going to discuss about RC circuits. An RC circuit is a circuit that consists of a resistor, inductor, and a capacitor. These circuits are mostly used in appliances such as TVs, radios, and microwave ovens. Today, we're going to tackle a problem of an RC circuit using differential equation. Suppose that we have a resistor that has a resistance of 4 ohms, a capacitor whose capacitance is 1/8 farad, and an inductor whose inductance is 1 Henry connected in series without external voltage. Find the equation that will determine the charge at any time t, given that the initial charge is 16 coulomb and the initial current is 0 amps. And also, find the charge at the time 5 seconds. As a visualization, this is how the components are connected in the circuit. The total voltage of the circuit is equal to all the voltage, the sum of all the voltages within the components, which is equal to VR, which is the voltage of the resistor, V inductance, V the voltage of the inductor, and the voltage of the capacitor. Since in theory, the voltage within the resistor, as stated in the Ohm's law, is equals to the product of the current times the resistance. And the voltage within the inductor is equal to its inductance times the instantaneous current over time. The voltage within the capacitor is equal to the charge times the reciprocal of its capacitance. So using this, we can substitute it here with their definitions. VR, which is equals to the current and the resistance. The inductor, which is equals to the inductance times its, instantaneous current. And the voltage within the capacitor, which is equals to the charge over the reciprocal of its capacitance. Since the current is equal to the first derivative of the charge over time, then we can substitute the i's here in terms of their charges over time. Here, we could state the voltage of the inductor as the product of its inductance times the double derivative of the charge over time. The voltage within the resistor, we could state this as its resistance times the first derivative of its charge over time. And this one stays as it is. As you can see, we now have a second order of differential equation. In order to solve the charge within the charge at any time of this equation, we could use the method of undetermined coefficients. So let me just restate this into simpler terms. Q over C. Here. 0. Now we can substitute this with their given constants, where the inductance is equal to 1 Henry. 1 Henry. Then the resistance, where's the resistance? Here, is equal to 4 ohms. And its given capacitance is equal to 1/8 farad, which is also 8. Now we can solve this using the methods of undetermined coefficients. Our first step here is to convert this into their characteristic equation. With the characteristic equation, we substitute this into into R, where R is equals to the first derivative of a function. Now, by substituting this, we can convert the equation into this. R squared. Oops. 4R. Then the Q remains at 1 since this is Q. R is equals to the power of 0. Q is equals to 1. So, as you can see, we have a second degree polynomial. And we can use the method of completing the square in order to find the specific r's. So we can transpose this to the other side, which becomes negative 8. Then we have a missing polynomial here, which we can say it's c. And by adding a constant c here, we can add another c here. So c can be determined by making it this one into half and squaring it, which becomes 4. Therefore, we're going to add 4 to each side. So I'm going to restate this into its factored form, which can be r plus 2 squared. And this one, I'm going to subtract this, it becomes negative 4. So I'm just going to put this up. Let's use the blue marker. Now we can square it, and since this has a negative, we're going to square a negative value. This becomes an imaginary value, which is 2 plus minus 2i. This one becomes r plus 2. Transposing it to the other side, it becomes negative 2 plus minus 2i. Okay, there we have our r. So in order to convert this into a solution, this one becomes a e to the power of negative times cosine with its corresponding coefficient inside, then plus p e negative 2t sine here. This is our initial solution without the coefficients. In order to determine coefficients a and b, we have to substitute this with their initial values. So these are our given initial values, which is the initial charge, which is 16 coulombs, and the initial current, or the first derivative of the charge, is equals to 0 amps. So this is the first derivative of the charge. So in order to get the differential equation, we have to use the product rule for both functions, where it is equal to negative 2e negative 2t cosine 2t plus, no, minus 2 sine 2t. Then the other one becomes b e to t cosine 2 and minus 2e into 2t sine 2t. Yeah. Then distributing the coefficients within becomes negative 2a e into 2t cosine 2t minus 2a 2t sine t. And the other one which is plus 2p e into 2t cosine minus v sine 2t. Simplifying the equation, it becomes negative 2a, it's 2b, e negative 2t cosine 2t minus 2a plus 2b e negative 2t sine 2t. So this is our differential equation to the following solution. Now we have our solution, which is a e negative 2t cosine 2 a negative e 2t cosine plus b sine 2t. Then its differential equation, which is equal to cosine 2t minus 2a plus 2b e 2t sine. Since we have two equations now, we can substitute them with their following initial values. So this one becomes so substituting with the initial value problem, the two equations become this one, 16 equals a e 0 cosine 2 0 plus b e 0 sine 0. And the other one, negative 2a plus 2b, negative 2 0 cosine 2 0 2a plus 2b e negative 2t 0 sine 2 0. We can cancel this out and also this one, since any number to the power of 0 is equals to 1. Also this one. Sine 2 0, if this becomes 0, then sine 0 becomes 0 too. So we can cancel the whole thing here. And cosine 2 0, this one becomes 0, cosine 0 is equals to 1. And this becomes 1. So we have one coefficient here. And this one becomes 1, 1, becomes 1, 0, so we cancel this out. Then this becomes 0 is equals to negative 2a plus 2b. Now, since we have a given a here, one coefficient, under the root coefficient, which is 16, then we can substitute this with the other equation. It becomes negative 2, 16 plus 2b. Then, using algebraic methods, we can say that b is equals to 16. There we have it. We have determined the two undetermined coefficients, so we're going to solve them to the solution, which is qt is equals to the a, which is 16, then b, which is another 16. There we have it. We have our solution, the charge at any time t. So in order to determine the charge at 5 seconds, we just only have to sub the t into 5. So in the equation, any t that you can see, just substitute it to 5. Then using your calculators, you can get the right answer, which is
16 e to the power of negative 2 plus 5 cosine 2 times 5 plus 16 e power of negative 2 times 5 sine 2 times 5, which is equals to negative 0.468 10 to the power of negative 3 columns,
or negative 1.00468 millicoulombs. Since we have a negative charge here, it also means that we don't have actually a charge. Since by getting the limit of the equation as t approaches to infinity, substituting all the t's with infinity, since we have a negative 2t here, it becomes 16 cosine 2 for infinity plus 16 2t. Oops. Sine 2t for infinity. Anything over infinity is equals to 0. So the limit of having a charge using this equation is equals to 0. So thus anything that is negative or with values below 0 is considered not a charge. So we can say, since we have a negative here, then q is equals to 0. So now we have determined our charge at any time t, which is equals to 16e negative 2t cosine 2t plus 16e negative 2t sine 2t, and also the corresponding charge at a given time of 5 seconds, which is 0.
First, declare the variables t being the independent variable and q as the dependent variable. Then, declare that variable q and t will be included in a differential equation. Then, enter the differential equation with variables q and t with their corresponding coefficients and order. The MATLAB will solve the general solution for the differential equation q as a function of t. The initial conditions must also be declared. Upon executing the commands for the initial conditions, the MATLAB will provide the particular solution which corresponds to the constants. Lastly, the MATLAB will display the graph by the syntax fplot for interpretation of the differential equation.